Welcome to a video on a MATLAB tool where I offer to you it's a standalone MATLAB file that will demonstrate how to use the steam tables within the MATLAB environment to get thermodynamic properties that you wish, nearly almost like magic. So let's go ahead and get started and see what I have to offer you. How many of you find that you're spending a lot of time seeking out thermodynamic properties from the steam tables, either both in SI units and English units? And in particular, the time that you're spending is not necessarily in identifying the phase of the substance, but in interpolating in between where you need a property value that's in between temperatures or in between pressures. Or in sometimes with superheated vapor, it's in between both a pressure and temperature. And boy, that can take a lot of time to do a double interpolation. So what I want to offer you is a standalone MATLAB file. Actually, it will be two of them, one in English and one in SI, where if you, the user, enter some two independent properties, the others can be looked up for you. So basically, the tools are going to involve the tabulation of tables A2 and A4, all bundled up into one file, as well as A2E and A4E for English system units. So this is a screenshot. So this is going to has a relative level of complexity to it. And so for right now, rather than jumping right into a live demo, I think I need to show you some screenshots to give you a feel for what this large file involves. And then we can go from there in a live demo. And so this particular file I'm going to show you is called steamwaterfunctions_si.m. So it's a MATLAB file. You can see that it's going to involve functions that I've created for you. And the units for this file will be SI units. So notice I'm doing a lot of documentation within the file, and that's one reason that the file is sort of big. Okay, so this is just the starting point of the file. A little further down the file, I've all in comments. So you see, these are all comments, right? They start with the %. I'm giving you a list of functions that I have created. So I have created these functions. These are not built-in functions built into MATLAB. They're functions that I've created for you. Okay, so you can sort of quickly peruse the list. There are functions that are associated with the vapor dome saturation conditions. We'll look at some details, and then a smaller set that has to do with saturated vapor properties. In other words, superheated vapor properties, the superheated phase. Okay, and so some notes before I move on. So since I'm the creator of these functions, I'm able to name them however I like. Okay, and so let me explain to you. It says function names designed to make sense. So for example, the first one, I've entitled it PSAT_KPA. Well, to figure out what that means is, let's look at the input. The input is T in degree C, and the output value is in saturation pressure. In other words, the pressure at which water boils for this boiling point temperature. Well, let's look at the function name. P, that's the output. PSAT, okay, PSAT, that's what we're looking for. The next is T as a function of T _ units. Okay, let's look down at another example. How about HGT? Okay, well, Hg would be the enthalpy of saturated vapor. Just like you're used to looking up on your tables, Hg as a function of T with units kilojoules per kilogram. Okay, so you say input is T, output is the variable Hg, the enthalpy of saturated vapor in kilojoules per kilogram. So do recognize that all my function names, both SI and similarly in the English system, they're all tagged with underscore units for units clarity, which is critical for this type of collaborative work, right? So it's terrible to blindly use someone else's work, okay, to leverage that work and get some results out of that work to save you time, but having no idea what it means, no idea what the units are. So there was some, I did some thinking when I created these function names, and then the work of creating the MATLAB functions describing to get the outputs from the input. So notice here, that's just the way the MATLAB functions work. So notice here, for our saturated properties, we've only got one input, and the input is either going to be temperature or pressure, and in one last case, H sub F. Okay, but one input variable and one output variable. Saturation, temperature, or pressure. Look at that: internal energy, enthalpy, entropy, specific volume, that type of thing. Okay, so that is the setup there. Superheated vapor. Remember, for superheated vapor, you've got to have two independent properties to set the state. Okay, and so, for example, let's look at this one: HPT underscore kilojoules per kilogram degree K. There's the units. Okay, H, that's enthalpy. That's the output. The next two letters, PT, those are the two inputs, pressure and temperature. See, like that. So HPT, enthalpy as a function of pressure and temperature. Next one, entropy, S as a function of pressure and temperature. Let's jump down to another one. And so finally, another one would be HPS, enthalpy as a function of pressure and entropy. Now, these functions are extraordinarily complex because they have two inputs, and that represents a double interpolation. So I hope that gives you a preview of what I've done to create the file. I've created a bunch of named functions with certain inputs in order for the user to get a desired output. I was circling the wrong column, wasn't I? Inputs in order to get a desired output. Again, we're stepping back before I dive in to give you a live demo. Taking some, here's lines 1, 2, and 3, simply the name of the file, beginning of the documentation, when I created the work, and then dropping all the way down to the end of the file. And notice here, it ends almost at 1,200 MATLAB lines. That's a pretty big file, isn't it? Well, part of the reason is there's a lot of comments in it, so it will be shrunk down, okay? But let me tell you about the basic overall organization of my files. So first is, so the top of the file is basic user instructions and the function list. You just saw the function list, user instructions, it's all comments, okay? The next block, after all the comments and instructions, is a demo block where I demonstrate how to use all the functions that I've created. So these are this is a standalone file where you can get a live demo. You can input your own numbers or simply use the input values that are put in and get a demo of the way the functions are called. So the next block is a demo of the function calls. Okay. For the saturated. The next big block is the same type of idea of demo of the superheated vapor function calls. And then the next block down is all of the MATLAB computer code or functions that comprise all of the functions I just showed you that are available. So this is basically the MATLAB coding of all the functions. Up here, you're going to see that the demos are really very short, very tiny little short pieces of MATLAB code. So I hope you get the idea of the organization of all of the thermodynamic property tool files that I'm offering you. Okay, so remember, we're not live, we're just looking at screenshots. And so this is that section where I'm saying, I'm giving you a demo of the way the functions are called for the saturation properties, okay, under the dome. Okay, so let's see, here's what I do. Let's say I'm trying to get the saturation pressure at a known temperature. In other words, at what pressure is it saturation at a given temperature? So, well, let's think. Okay, let's do one in our heads before we get into that. At a temperature of 100 degrees C, 100 degrees C, what would you expect the saturation pressure to be there? Well, 100 degrees, that sounds like the boiling point at 1 atmosphere, doesn't it? So the saturation pressure would be 100 kPa. That's just in your head. Well, here's a demo of the way we can get the saturation pressure at any temperature. In MATLAB, I'm going to say T equals 201. Well, that's got to be in degrees C. Okay? Shame on me for not putting degrees C, but I didn't. I failed to do that. T is 201 degrees C. Next is the function call. It says PSAT, that's the variable that I'm assigning saturation pressure to, equals, well, the function name, PSAT T underscore KPA with the input of T. Simple as that. That's the function call that looks for saturation pressure. And so notice here that if you went to your temperature table, you wouldn't find 201 tabulated, would you? You'd probably find 200 and 210, and you'd have to interpolate. The nice thing here is MATLAB does the interpolation for you. And so in my demo, you can see I'm just preparing a text string to nicely put the result of 201 temperature and whatever the saturation pressure is out in the, I'm having a mental lapse on that output block, the command window. It goes to so the output block goes to the command window. So next example, next demo is given a certain pressure, 302 kPa. What's the boiling point? What's Tsat? What's the temperature at saturation at 302 kPa? Same idea. I'm going to assign variable Tsat in MATLAB equals the function call, the function name, Tsat P in degrees C, with P as the input. So I hope you get the idea. So you can use this as a standalone tool if you're doing a homework problem and you need to find the saturation temperature at your own pressure. You just put in your own pressure. Instead of 302, you put in your number, you click your run button, and you're going to get a result right then and there. These demos continue on, so you can see I'm demoing each one of the functions that I've created for you. Okay, a little more complex. Demo of the superheated vapor thermodynamic properties. Well, here do you see now, oh, I'm doing a little better. Look, I'm doing a little better of labeling my units of P, 107 kPa, input temperature of 367. Now, you know, you'd never find these in the superheated tables in the back of the book, would you? But this single function call, and I'm going to assign the MATLAB variable H to that. MATLAB variable H is the function call H given pressure and temperature in kilojoules per kilogram. Input values, P and T, okay, that's the function call. And then all I do is prepare my output to the command window for the demo. Same ideas, oops, demo of SPT. So I'm going to enter a pressure and a temperature, basically the same demo numbers. And this time I'm looking for entropy S. So I'll assign S and then call up my function SPT in kilojoules per kilogram degree K with my inputs P and T in parentheses. I hope this is a crash course to give you a general idea of how these function calls work. here's a screenshot of the command window output of the demo. So when you click the run button in MATLAB, this is what you'll get for the, so it scrolls on down. Like the next page, I believe, is going to give you the superheated properties, but this is all, this represents demos of all of the saturation function calls for H2O. Okay. And look at how nice it is. So do you see my style is I say what my variable is, Hg, I give the units, the value of that property, and also say at what input, at P of 507 kPa. And that's just sort of good practice as you're using the tool to set up your output. So working with others, not only to just to give a number, but also to give units and what it is. This is the demo command, command window output of the superheated call. So here for superheated vapor, remember, you have to put in two independent properties to get out the needed property. So the enthalpy of a pressure of 107 kPa and temperature of 367 is 3210. And so just to give you a little background, how do you get all this work? How do these functions work? They all key in off of the interp1 built-in function in MATLAB. Okay, so this is just a screenshot of when I type in help function in MATLAB. This is what I get from MATLAB. And it helped me limp along. I learned a lot from looking at some of the MATLAB videos in YouTube and on the MATLAB website itself. It takes you to YouTube on how to, some tips on how to create the functions. So here's the guts behind it. So here's a screenshot of the, in my function library. So notice here, we're scrolled down to around line 200 in the file, okay? Let's look at function named psat_t underscore kPa. That's the name of the function. What's being returned is PG, and the input is T. All right, so that's the function definition. There's the end of the function, okay? Here's the way I do this. So I've taken from the book, I've copied and pasted values of saturation temperature, that in the temperature table, that long list of temperatures. There they are, right there. It's a vector, okay? So, and the vector is called Tsat degrees C. In brackets, there's all those values. Then I went to the next column, the pressure column. That's Psat, Pg, okay? That's also a vector with the same number of entries. And here it is, Psat, kPa. So that's, for this particular function, that's all we need. We don't need the whole table of properties. We just need Tsat, Pg, and Pg. Those are our X and Y vectors. And so here is our function. Here's our output, PG. That's our interpolation value, pressure. That's what we're trying to find. We're going to use the MATLAB built-in function interp1, and then our inputs into that interp1. Here's our X vector. That's T saturation. Our Y vector, T saturation, in our input variable X, which is T, temperature, that's coming in from the body of the MATLAB program, in our case, the demo program, okay? I hope does that make sense? Let me repeat. This is what's going, this is the output variable PG. So there it is right there, okay? Interp1 is the built-in function we're using. So we have to know, well, what kind of inputs do I need? Here's my X vector, T saturation, Y vector, P saturation, and input number that's next to or associated with the X vector of T. That's coming in from the program. I hope that helps you understand what's behind the tool. Now, superheated vapor functions are much more complex. And I've had some previous experience doing that. I didn't just come up with this just off the top of my head over a weekend. I've had a lot of experience doing double interpolation, both manually and then also in Excel and also in Fortran. And so I simply leveraged what I'd already done and put it into the MATLAB format. But these are a double interpolation is extraordinarily complex because you think about superheated vapor in the back of the book. Remember, there's various tables of different pressures. So you have to seek out, given a pressure, you have to seek out the two tables that straddle your pressure. That's complex on its own. And then decide, then you would interpolate there, and then finally interpolate on, say, temperature, if you've selected temperature as your independent variable, to get the desired output. So in this particular superheated vapor function, HPT, in other words, that is enthalpy as a function of pressure and temperature, and the units of this function are in kilojoules per kilogram. This is in the SI MATLAB file. So I won't go into the nitty-gritty details of how I created this complex function for you. If you have detailed questions, happy to talk to you about it offline, one-on-one. But anyway, it's a lengthy function for the enthalpy of superheated vapor as a function of pressure and temperature. And the others get even a little more complex than that. Well, here's my key to go live. I'm going to have to try to remember to show you how would you get to this file? How would you possess this file? And then I'm going to try to give you a little live demo in the MATLAB environment of how the file works. Okay, so I've just gotten out of PowerPoint. Let me show you how to access this file. Let's go to J's Toolbox, and here we are at J's Toolbox at VT domains, jstoolbox.vt.domains. So we'll scroll down a little bit, and in this menu, we're going to come down to MATLAB. So I clicked on MATLAB, and this is one single page on my website. So we're going to shop for water steam properties in SI. Here we go. SteamTables SI. So you can download this file and possess it. A little note, repeating from my little intro. I had to save this file as a .doc file. It was the only way that my web host would allow me to post this file. MATLAB files have to be .m file type. And so you will download that file, open it, let's say in Notepad. Notepad is a good way to open that file, because it's all just ASCII characters, okay? And save as to a .m file once you're in Notepad. Save as .m, the file name .m, to make it a MATLAB file. That's the only little trick on getting access to this tool file off of J's Toolbox. Okay, now let's go to MATLAB. MATLAB's already loaded. I've got to move my Zoom windows around a little bit. And so welcome to the Steam Water Functions _SI MATLAB file. Okay. So you can see that I'm going to scroll down so I can demonstrate to you that it's a big file. So you see, so most of the file is taken up with the function definitions. There's the end of the file. I'm going to go back up to the top. Okay. You can see that I start with a lot of comments, including the pick list, the list of functions available both under the dome, saturation properties, as well as superheated vapor properties. So that's the end of all my comments. Here's the tried and true clear commands that I use when I start all my MATLAB tools. And then you can see, now here's the demo block. I'm going to scroll down a little bit. See, here's the demo block where I'm demonstrating the use of each function call. And I've tried my best to sort of in comments talk about what I'm demoing. So here's, we've inputted a temperature. Well, let's change the, instead of 201, instead of the demo 201, well, let's make it 209. So we know 209 is not going to be in the book, is it? All right. So a temperature 299, what's the saturation pressure? At a pressure of, instead of 302, well, let's make it 307. We know 307 is not going to be in there, et cetera, et cetera. So you see that we, the user, have control over these input properties, values. And each time we're calling, what we're doing is we're calling, here's the function call. There's the function call looking for the saturation pressure at a temperature of 209 degrees C. Okay, here's the function call. So you get the idea. But we just keep scrolling down. These are all just demos of all of the available functions. So for example, if we're looking for U sub G as a function of temperature, there it is. You just put a number in, function call is done for you. I've gotten to where I like to create the output over in the command window. And then as we continue to scroll down, now more demos, demonstration of function calls for superheated vapor properties. It's the same idea. So you see, if we, instead of a pressure of 107, we could make it 108. Okay. So we've got control over this. Looks like I'm doing a better job of defining my units over here for superheated. Okay. More function calls, more demos. And now this is going to be the end of the demos. They all work. Okay. And then finally, see, I've got a percent. So I've got a new sort of block here. And this is my function library. If you possess this file, you don't mess with anything below function library. Don't change anything down below here. Well, you're on your own if you do, but these are the functions that I've created. And so you can see for this one, just like I explained in the screenshot, function name is psat_t underscore kpa. And here I'm going to try to highlight it. There it is. There's the function name. Okay. The input is temperature T that we defined way up higher. Okay. The output is PG. It's going back to the program as the returned output. You don't mess with any of this. So here is the X vector, T saturation. Here's the Y vector, P saturation. And here is the built-in function interp1, interpolation for X vector, Y vector, X value known, and here's the output, PG, Y, interpolated Y. And it just goes on and on like this. So I've just taken the time to create all the function calls needed to create this library for you. Okay, hope that gives you an idea. So I'm going to click run. Boy, let's hope it runs. Ooh, look, we got a lot of information in our command window. I'm going to scroll up to the top. Okay. You may recall that we fat fingered in a new number. Look at that, temperature 209. We've got a PG of 1870.8 kPa. Okay. We fat fingered in a new pressure, 307. Okay. And so we've got a saturation temperature of 134.05 degrees C. And it goes on and on like that. And so this gives you the ability, if you wish, to use this as a standalone tool. If you have particular input values, you can immediately get the desired output values. Similarly, in the superheated tables, same demos where we're putting in a pressure and temperature and getting out an enthalpy. So the double interpolation is performed for you. Okay. I'm hoping that you see some value in this tool. So to use it as a standalone tool or go a little further with it. But it certainly does, it certainly will serve as a standalone tool if you desire to learn a little bit how to use it and then use it in some of your problem solving. Okay, so I think that's a pretty good live demo in the MATLAB environment of what did we cover? We covered steam water functions underscore SI, so it's SI units dot M. All right, so I'm going to minimize MATLAB. Oh, I'm back to my browser now. So while I'm still here, you say, well, wait a minute, I've got English units. So let's scroll back down and see if we see SteamTables English. You would download a different file if you needed to work in English units. We were just looking at SteamTables SI. Okay, we've had a live demo to show you how to access the MATLAB files, shown you in the MATLAB environment how that file worked, a little bit about what's behind the functions that I've created for you. All those functions depend on the built-in MATLAB function interp1. There's a screenshot of what I just showed you, SteamTables SI. If you're an English system, different file. And here's our takeaways. Here's our recap. You've got separate files for SI and English units. Okay. You can use those files as a standalone property getter. Hopefully it'll save you some time. Now, once you get some familiarity with doing that as a standalone tool, you might start head scratching and say, I think I could use save as, and I could delete all those demo functions, and I could put some of my own problem solving MATLAB commands in that block. So won't go into it in detail, but let you think about that. But you can use save as, that base file, and make the calls only to the functions you need or any kind of specific application you have. In other words, delete unneeded demo function calls. Right before I started the video, something did come to me, and I added this in the last slide. It's very much of a caution. You really need to understand the fundamentals of looking up thermodynamic properties before using this MATLAB thermodynamic property lookup tool. It's really important that you fully understand that. For example, you need to really understand, I need to have two independent properties to define a state. I've got to have two independent properties. That's what it takes to define the state. And a good feel for what's an input property and what's an output property. And so those are a couple of cautions that I would suggest you think about before you start blindly using somebody else's work. The other thing that does come to me is that clearly I'm not aware of any instructors who correctly would say, yeah, bring your PC in when you take a quiz or test to get property values. That doesn't appear to be acceptable right now. So you do have to be aware that you need to be able to fully understand how to interpolate on your own so that you will perform well on quizzes, tests, and exams. So that's going to be that's an important skill to have. But it's my hope that this type of tool, MATLAB tool, if you're taking or have taken MATLAB, I'm hoping that this kind of tool can help you extend the knowledge and skill that you've developed from the previous class into your thermal fluids heat transfer classes as well. Okay, I hope that helps. Give it a try. If you've got the time, download one of those SteamTables files, give it a try, at least hit the run button, see how it works for you, and go from there. So good luck with it. And like I say, I hope it helps.